Hello everyone, this is Dhananjay, working as an assistant professor, Mechanical Engineering Department, Vigyan Institute of Information Technology. This is the course Fluid Mechanics and Fluid Machines. For BTech Mechanical Engineering, we are 19, second year, first semester batch. This is lecture number 2, Properties of Fluids, under Unit 1, Fluid Statics. These are the topics which we are going to cover in the lecture number 2. Those are the introduction of properties of fluids, introduction of fluid statics, definition of fluids, the types of different kinds of fluids, the properties of fluids, and a simple problem and as an assignment problem. In the properties of fluids, we are going to cover the density, specific weight, specific volume, and specific gravity. Coming to the introduction, fluid mechanics. Fluid mechanics is the branch of science which deals with the behavior of fluid which are in rest as well as in motion. The fluid may be a liquid or a gas. The fluid mechanics is classified as the fluid statics, fluid kinematics, fluid dynamics. Fluid static is nothing but the study of fluid at rest condition. Fluid kinematics is nothing but the study of fluids in motion. Here the pressure forces are not considered, whereas fluid dynamics also is the study of fluid in motion, but the pressure forces are considered. In fluid statics, there is no motion of a fluid. There is no motion in between the layers of a fluid, and there is no shear stresses generated in between the layers as there is no motion in between the fluid layers. Fluid kinematics deals with the velocities, accelerations, and the patterns of flow, whereas fluid dynamics deals with velocities, acceleration of fluids, with the force or energy causing them. So we can say the fluid mechanics is a branch of science which deals with the behavior of fluid. The fluid may be in gaseous state or in liquid state. So we are going to study the behavior of fluid at rest as well as in motion also. So thus the branch of study again classified into three types. What are those? Fluid statics, fluid kinematics, and fluid dynamics. So the name itself saying that fluid static means there is no motion. So we are going to study the behavior of fluid in rest condition. So here there is no motion, so the fluid is in rest condition, so there is no generation of shear stresses. Fluid kinematics deals with velocities and accelerations and patterns of flow, whereas fluid dynamics deals with the relation between velocity, acceleration of fluid with the force or energy causing them. So these are the main three different branches of fluid mechanics. When it comes to the definition of a fluid, fluid is a substance which is capable of flowing and deforms continuously when subjected to external shear force. Yes, fluid is a substance which mainly has a capability to flow and it has to deform continuously when it is subjected to an external shearing force. The basic characteristics of a fluid are: it has no definite shape, but it conforms to the shape of the containing vessel. Even a small amount of shear force can cause it to undergo a deformation which continues as long as the force continues to be applied. So these are the two basic characteristics. One is it has no definite shape of its own, but it conforms to the shape of its vessel. Second one, even a small amount of shear force exerted on a liquid will cause it to deform continuously, which continues as long as the force continues to be applied. A fluid may be classified into three types. We can say there are three kinds of fluids. We can say there are three kinds of fluids. One is ideal fluid, second one is real fluid, third one is continuum fluid. So fluids are three types: ideal fluid, real fluid, continuum fluid. So here there is no ideal fluid exist in nature. We can say no such fluids exist in nature, as we are termed it as ideal. Ideal fluids are not existed. When come to the real fluids, yes, real fluids are existed in nature, which are available in nature. Continuum fluid, a continuous and homogeneous medium is called a continuum. Okay. When come to ideal fluids, has no viscosity, has no surface tension, and is incompressible fluid. Water and air can be treated as ideal fluids under certain conditions, whereas real fluids are viscous. It has surface tension and it is very much compressible as well. It has certain density. When it comes to continuum fluids, the overall properties and behavior of the fluid can be studied without regard for the molecular and atomic structure. Here you can see that for ideal fluids there is no viscosity. Here you can see that there is no compressibility. When it comes to real fluids, you can observe the viscosity of a fluid and you can observe the compressibility of a fluid, and ideal fluids flow patterns are always uniform. But in real cases, it exists with different flow patterns. Here you can see there is a surface tension observed, means there a thin layer formed at the top surface of the fluid. Next, here the density, fluid mechanics property, density is also called as mass density. It is the ratio of mass of fluid to its volume. Ratio of mass of fluid to its volume. It is denoted by rho. Symbol rho. The SI units are kg per cubic meter. Kg per cubic meter. Mathematically, it can be written as mass of fluid per unit volume of fluid. The density of liquids may be considered as constant while that of gases changes with variation of pressure and temperature. The value of density of water is 1 gram per centimeter cube or 1000 kg per meter cube. Here the picture clearly stating different densities of different liquids. Here you can see there is a honey. It is very viscous. Okay, here you can observe some soap liquid. Here you can observe refined sunflower oil. Here you can observe some other different density liquid. Okay, so these all are not going to mix each other because of their density. Okay, next comes to the specific weight or weight density. Specific weight is also named as weight density. It is the ratio of weight of fluids to its volume, and it is denoted by a small w. The SI units are Newton per cubic meter. Mathematically, it is written as weight of fluid per volume of fluid. We can say the weight of fluid is nothing but mass of fluid multiplies acceleration due to gravity. We already know that the density is the ratio of mass of fluid to the volume of fluid. So here we can observe there is a mass of fluid, there is a volume of fluid. So these two commonly called as density. So finally it is density multiplies acceleration due to gravity. The value of specific weight or weight density for water is 9.81 into 1000 Newton per meter cube. Here you can observe the picture. There are two objects placed which are equal in volume but different in mass due to their density. Next, specific volume. It is the ratio of volume per unit mass. Specific volume SI units are cubic meter per kg. Mathematically, it is the ratio of volume of fluid per mass of fluid, which you can observe that which is a reciprocal of density. So we are writing it as 1 divided by mass of fluid per volume of fluid, that is 1 by rho. It is commonly applied to gases. Next, specific gravity or relative density. Specific gravity also termed as relative density. It is the ratio of density of fluid to the density of standard fluid. It is a dimensionless quantity as the numerator and denominator both are densities, and it is denoted by symbol S. For liquids, the standard fluid is water. For gases, the standard fluid is air. You can see specific gravity for liquids equal to weight density or density of liquid per weight density or density of water. For gases, weight density or density of gas, weight density or density of air. So which is for liquids, this is for gases. For gases, the standard fluid is air. For liquid, standard fluid is water. Weight density of a liquid is equal to specific gravity multiplies weight density of water, that is specific gravity multiplies 1000 into 9.81 Newton per cubic meter. The density of a liquid is equal to specific gravity multiplies density of water. That is, specific gravity multiplies 1000 kg per cubic meter. If the specific gravity of fluid is known, then the density of fluid will be equal to specific gravity of fluid multiplied by the density of water. For example, the specific gravity of a mercury is 13.6, hence density of mercury is 13.6 into 1000, that is 13,600 kg per meter cube. We can see a simple problem. Calculate the specific weight, density and specific gravity of 1 liter of a liquid which weighs 7 Newton. Here the given data is 1 liter and 7 Newton. 1 liter is volume, 7 Newton is weight. Here weight 7 Newton and volume 1 liter, which is equal to 1 by 1000 cubic meter. So calculate specific weight. What is specific weight? It is the ratio of weight to the volume. What is the weight here? 7 Newton. What is the volume here? 1 by 1000 cubic meter. So the specific weight is 7000 Newton per cubic meter. Next, when it comes to density, density is nothing but it is the ratio of mass per unit volume. What is the mass here? We have weight 7 Newton. Okay, 7 Newton. So mass is 7 by 9.81. Volume 1 by 1000, which gives 713.5 kg per cubic meter. Next, specific gravity. Density of a liquid, already we know that, and density of a water, which is standard. So 713.5 divided by 1000, which is 0.7135. Next, these are the assignment problems. Calculate the density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. So here we are getting two given data. One is 1 liter of petrol, means volume of 1 liter, which is 1 by 1000 cubic meter, and specific gravity 0.7. Here what they are going to ask, what they are asking is the density. What is density? Density is the ratio of mass per unit volume. Okay. Specific weight. Specific weight is the ratio of weight per volume, and weight, mass into acceleration due to gravity, is nothing but weight, which is in newtons. Okay. Next, assignment problem 3. A liquid having a specific gravity of 0.82. Here it is they are giving 0.82 specific gravity is filled in a vessel. Calculate density, specific volume, specific weight. Okay, so what are the given data here? Liquid having specific gravity of 0.82 filled in a vessel. So calculate density. Okay, so we can calculate density very easily, as the specific gravity formula is density of a fluid per density of a standard fluid. Okay, so already we know that specific gravity is 0.82, so that multiplies with 1000 will gives you the density of a liquid. Next, specific volume. So here it is mass, here it is density, here it is specific gravity. So please try all these three problems. So here it is end of the session. Thank you.